Okay, so we're going to do percentage of error, and this will be a short video. I'm going to just go through a little bit about what percentage of error. We're going to talk about desired measurements and percent measurements and error ranges. So first of all, the percentage of error is a way of expressing the difference between a known or desired value and its measured value. So the formula that you're going to want to memorize to calculate percentage of error is you want to take the error of measurement divided by the quantity desired times 100 because we're getting a percent. So whenever we're looking at a percent, we want to do multiplied by 100. But the first thing you need to realize is when we're talking about a percentage of error, we're looking about like how will it affect our outcome? And it's really important in pharmacy because if you take something really heavy, like let's say a car, and if you're off by 5 grams on the weight of a car, does that matter? No, it doesn't matter because it's such a small amount. But if we're looking at a drug dosing, let's take a drug like fentanyl, what we measure in micrograms. So the smallest error in measuring fentanyl could be a very large error for a patient because fentanyl is a very dangerous drug, and if it's overdosed, the patient can go into respiratory failure or cardiac arrest because they could die. So you got to keep that in mind when you're thinking about pharmacy, and a percentage of error is really important. So first we want to figure out the error of measurement because that's the first part of your formula. See right here, the error of measurement. So what is the error of measurement? So it's the difference between the measured value and the desired quantity. So it's just that what we actually measured and what our quantity we want is, and you subtract that, and that's your error of measurement. So let's take an example. You are to dispense 50 milliliters of sertraline solution. Um, the original measurement shows 50 milliliters. When you verify the amount using a more accurate graduated cylinder, the actual amount is 54. What is the error of measurement? So our actual one was 54. We desire 50, so we have 4 milliliters in error measurement. Okay, so it's pretty simple. It's just subtracting that difference. So let me go back to this. Now, if this was reversed, let's say we actually we got a negative number. Whenever you get a negative number in error, percentage of error, you want to use an absolute value and you just get rid of that negative number. Because we're figuring out a percentage of error. So don't let that negative number throw you off if you're taking, if our actual value was 50 and we wanted 45 and we had a negative 5, um, then we would just make it an absolute value and just get rid of the negative. So something to keep in mind. So when you're calculating measuring of error, you first have to calculate the error of measurement and then you put it in the formula. So you're dispensed 120 milliliters of liquid. The original measurement was 120. When you verified the amount using a more accurate graduated cylinder, the amount was 126. What is the percentage of error of the original measurement? So what is your error measurement? 126 minus 120 equals 6. So we want to put it in this formula. So our error of measurement is 6. Our desired quantity is 120. We want to multiply that by 100. So 6 divided by 120 times 100 is a 5% error, which is quite a bit in pharmacy. You don't want a 5% error. Usually 1%, 0.1, depending on the units. Like if it's micrograms, it's less compared to a gram because gram is larger. So the other thing we want to talk about in this video is error tolerance range. And I often refer to this as standard deviation because it's a range plus or minus 1 or plus or minus 2, and it's a range that we have to fit into. So it's an acceptable range. So when is it acceptable? So a lot of times they're going to give you a tolerance value, like a percentage value that is acceptable. And when they give you an amount, you can calculate that. So that's kind of what we're looking at here. So here's an example. This is actually very easy. So you are to weigh 60 grams of cream base for a topical compound. So we extemporaneously compound in community pharmacy, and you can do it in institutional pharmacy as well. It just depends on. But you're going to do 60 grams of cream That's what you want, and your air tolerance range is 3%. So they're allowing you a tolerance of 3% plus or minus. So what is the lower weight limit in grams and the upper weight limit in grams, or the range, what would be this in a 3% air tolerance range? Okay, so the first thing you want to do is you want to convert your air tolerance range of 3% to a decimal. So 3% in a decimal is 0.03. Okay, and then multiply that target weight by the air tolerance range. So your target weight was 60 grams. So 60 times our 0.03 gives us 1.8 grams. So that is our plus or minus range, plus or minus 1.8. So to determine the range, you're going to take your 60 grams and you're going to subtract 1.8 and you're going to get 58.2. That's your lower range. And then your higher limit, you're going to take the 60 grams and you're going to add the 1.8, which is going to be 61.7. Oh, nope, I think that's supposed to be 61.8. I must have typed that wrong. Sorry, 61.8. And that's going to be your range. Okay, so if we weigh it and we fall into this range after we make our topical compound, we know we're good. We're good. If it's below 58.2 or above 61.8, then we have to redo it. It's not good. So that is your air tolerance. So that is it. That's how you calculate air tolerance and percentage of error. If you need to find more videos out there, there are a few of them. I can upload them. They're kind of long, but this is pretty short and quick and pretty easy to do.